Okay, real quick here. I've heard it already being discussed as you guys looked at the topics for tomorrow. What is double triangles? What do I mean by that? I'm talking, if you look at the last question on your quiz, number 9, how far away were the dogs? That two triangles in one, two right triangles in one diagram. Okay, so you guys had to take, this side right here. I'll call it X, because here's where the dogs were there. I'll call it Z. I don't know what that is. It's embarrassing. That's what it is. You had to find the distance between the dogs there, so you had to take that side in the big right triangle and subtract it from that side. Okay, that's what I'm talking about as far as double triangles go. Now, will I ask for that side tomorrow? No, maybe, maybe not. I don't know, but that's what I'm talking about with double triangles. Okay. I don't really have to go over much on this quiz. You're going to see a lot of it again tomorrow. You will see a Hills and Sass one tomorrow. Other than that, you guys pretty much, you did a nice job here. Okay, just remember with number 1, angle of elevation, you're looking up or down? Up, so that's the angle I needed right there. Okay, you're always looking up to elevation. We all good with this here, this quiz? Before we go hardcore review. All right, let's first start with what is available to you to practice for tomorrow, okay? Because I'm throwing a lot of problems out there, and then it's up to you, okay? It's up to you. You guys know my philosophy. There's no excuses. All right, if you get a bad grade, look in the mirror. Start on page 52. Start on page 52 of your packet. On page 52 to the right, you will see all the formulas you're responsible for. I am not giving out law of sines and cosines, as you know. I'll cover up SOHCAHTOA tomorrow, even though, let's face it, at this point, if we don't know how to spell SOHCAHTOA, I don't know what to tell you. Okay? But your 30, 60, 45, 45, 90 rules are all there as well. All right, so all the formulas you need for tomorrow. At the bottom of the page in the oval, those are textbook questions you can try. All right, flip the page over. Those are the answers to the textbook questions. Boom, look how convenient that is. Then you start the packet questions. I put a slew of them in there, a ton in there of packet questions. All right, at the end of the packet questions, there, very last page of your packet, there's the answers to them. Convenient. And then if you want to keep grinding, I respect that. I showed you on Aspen, there's a folder that says extra practice that breaks it down by Hills, Sass, 3060, law of sines, law of cosines, SOHCAHTOA problems. If you are struggling and want more practice, look in the folder. Okay, look in the folder for me. So I don't know what else I can provide to you tomorrow. It's in your court now. All right. Just a heads up, be ready to factor tomorrow, right? Be ready to factor. You're going to set up a proportion, cross multiply. Hey, I got to factor this. Just wanted to give you a heads up. Even though at this point, should that be a shock in here? Probably not, but just wanted to give you a heads up. Anything else you want to go over here before I start just diving right into it and just getting crazy? In your packet, number 6, we're going to start out with that one. All right, we're looking for what's the distance the ship traveled from point A to D, so AD. I just want thoughts, because I refuse to say we're doing it this way, because there's actually 2 different methods we could do, find AD. All right, and I refuse to say, hey, we're going to do it this way, and that's the only way. So I'll open it up to you guys. I don't want to call on numbers for this question. Thoughts on how I can find AD? Because if you take a look at it right now, AD is a full side in what triangle? Triangle ADB. Is that a right triangle? No. So if you wanted to use SOHCAHTOA on that triangle, it's not happening. Okay, but Naomi? Yep. So basically, here's what Naomi's saying. If you want to find AD, you better find AC and subtract DC from it. Yes? And why can I do that? AC and DC are both full sides in what type of triangles now? Right triangles. This is my double triangles problem I'm talking about. All right, double triangles. All right, so let's start with finding AC. Again, only use values from triangle ABC. What angle am I given in triangle ABC that I can start with? Let's roll 20. What angle am I given? 7 degrees. So everyone look at 7 degrees. What is side AC that I'm trying to find relative to 7 degrees? Is it opposite hypotenuse or adjacent to 7? Here we go. 17. It is adjacent. The other side that I know in that triangle ABC is 125, and that is what to 7 degrees? Yeah. 11. Opposite. All right, everyone, what do I use with if I have the adjacent and the opposite side? Which ratio? Tangent. All right, here we go. Tangent of, what was the angle you used? 7 equals opposite 125 over adjacent. I'll call it Y because I already threw an X on AD. So everyone all right on how to find AC? Got to use values from the same triangle. Don't try to mix and match values on me. Values from the same triangle. All right, and then we're going to find DC now. Here we go, DC. Only use values from that triangle. What angle do I know in triangle DBC there? How you go, 19. What angle do I know? 16. Here you go, 19 again. What's the DC in that one compared to the 16? That's adjacent. How about the 125? All right, so I'm going to use, once again, tangent. But now I'm going to use tangent of 16 equals 125, and I'll call this one Z. Don't round those values because you're not done with the problem. When you find AC and DC, keep that full calculator display, subtract them, and then you guys can finish that problem right now and look in the back of your packet to see if you got it right. Everyone okay? You look in the back, see if you got it correct. Guys are all good? Questions going? Okay, pencils, pens down, please. There is another way I could have approached this using law of sines and law of cosines instead. Remember at the very beginning, I asked you guys what triangle AD was a part of, and what did you guys tell me? It's a part of triangle ADC, right? This one, right, or ADB. But it's not a right triangle. So I couldn't use sine, cosine, tangent. But I could use, ready, watch. Let me clear all that out. Could you find other angles in that triangle? Do you have enough geometric knowledge to find other angles in that triangle? Okay, what's the angle next to the 16? Here we go. What's the angle next to the 16? 164. Could you find the third and remaining angle in triangle ADB? 9. Okay, ready? So I could, you ready? X over what? What's the angle opposite? So I could do X over sine of 9 equals, here we go, I could use the 7. What's the side opposite 7 in that triangle? Oh, you got, again, all right, here, I'm glad people are doing this. When you use law of sines, you can only use values from the same triangle. You can't mix and match between them. So what side in triangle ADB is across from 7 degrees? DB, do I know that side? No, but ready? Stay with me. Could you find that side? Okay, how could you find that side? Go to this triangle now, ready? DB over, what angle's across from DB in this triangle? Sine of 90, I can do that here, equals, what's another side angle relationship you know in that triangle? 125 over sine of 16. And then once you find DB, whoop, plug it in, and I'm going to X. So you could use 2 law of sines there. All right, 2 law of sines. All right, just want to give you guys options for tomorrow. Want to give you options. You good there? Any issues? All right, now the next set of problems I'm going to do, I'm sorry to do this to you, but your packet didn't do any justice for this, and I need to go hardcore. I picked questions off the extra practice, so if you want to copy them down or you want to watch what we do, it's your call. All right, but the next set of questions are going to come from the extra review, which are not in your packet. They're on Aspen, though, if you want to do them. Okay, here's my next question right here. And hopefully I'm going to start open some eyeballs here with how tough this may be. Again, these are the type of questions I posted on Aspen under the extra practice. Haven't seen one of these bad boys in a while. You got to get ready for tomorrow. Okay. There is no way you're going from that side of 6 to X in one step. No shot. Why not? The 6 is in what type of triangle? A right triangle. Good. Can we get more specific? A 30, 60, 90. And the side X I'm trying to find is in what type of triangle? You're correct. Side X is in what type of triangle? Okay, so there's a problem. So I'm going to need a step in between because I can't go right from AB to DC. No shot. What side am I going to have to find? The in-between side. AC, right? The one they have in common. All right, let's do it. Let's do it. So I'm going to find AC first. What type of triangle do I have on top? 30, 60, 90. Dust the cobwebs off. Dust the cobwebs off. What are my rules? 3. What are my rules here? Just like we did it yesterday. That's what I'm talking about, Charlotte. Good. Where's the 6 across from? Where's AC across from? All right, got to get me there then. I need to go from here to there somehow. You're not going to do it directly, remember. We got to go backwards to the 30, and then we'll go to the 90. All right, so what am I doing to this 6? Whoop, to go that way. Okay, if it helps you set, some of you may not see it, if it helps you set it up. 6 is equal to what in the chart? X radical 3, and you're trying to get to where in the chart? Just X. So what do you want to do with the radical 3? Yeah, you're darn right. And then we're going to have some self-respect. Why? Can't have a radical in the denominator, so what do I need to do with it? Multiply top and bottom by radical 3. Yep. Oh, we're still grinding. What do you get at the top? 6 radical 3 over radical times itself is the number. Still grinding. 2 radical 3, which is across from the 30. Now how do I get to AC, which is across from the 90? What do I do with 2 radical 3? So 2 radical 3 times 2. Now we switch gears to what triangle? Dust them off. What are my rules? It didn't work out as well as I wanted it to. 24 rules. Where's the 4 radical 3 I just found across from in that triangle? It's across from the 45, yep. And not that I needed to know, but what's across from the other 45? Okay, I need to know the side across from 90, right? So I need to take the x, which is 4 radical 3, and do what with it? Multiply it by... We going hardcore, aren't we? Yeah, we are. Four radical. Okay. You know, I obviously wanted to do this problem so I could review 30, 60, 45, 45. But there's a secondary reason I wanted to do this, and I'm starting to hear it now. I don't need to know my rules. I'll just do sine, cosine, tangent. I'll just do law of sines. Agree, right? Problem, though. Every time I have you do a 45, 45, 30, 60, how do you always usually leave your answers? Radical form, correct? Is a law of sines or doing opposite over hypotenuse going to get you simplest radical form? No, it's going to get you decimals, right? Okay, so be aware of that, all right? Don't go into tomorrow thinking, forget those rules, I'm just always going to do sine, cosine, tangent. You can, but if the directions say simplest radical form and you have, I don't know. What was our final answer here? It's 4 radical 6. You're like, oh, I'll just do that, yeah. And then all of a sudden your calculator, that's staring you in the face, and you're like, math, change it back. Oh, I don't have change it back to a radical. Okay, see what I'm getting at there? Know your rules. Okay, know your rules, because your calculator, sorry, will not turn it into simplest radical form for you. All right, that's what you're going to get, 9.797, and you're not going to answer the question for me. All right, so just a heads up. All right, next one. Also not in your packet. Got it off the Aspen Extra Review. Just a warning, I'm going to get fired up in a second. More than I am right now. I'm going to go through the roof, and some of you may know why, because you did it on your first quiz. Let's just spray. Thought some lotion was going to come out. Okay, why am I going to get fired up? Is there any reason to put a 45-degree measure up there? Is there any reason to put a 30? Is there any reason to put a 60 in there? No. No. If you find yourself doing that tomorrow, probably what type of problem is it? Hill-Sass. Plus, you can also look at the diagram. What type of triangle is the large one? It's a right triangle. Hey, you see that dotted line? What do we usually call that nowadays? Altitude, and it's being drawn where to the right triangle? The hypotenuse. Altitude to the hypotenuse. Discussion's over. This bad boy's a Hills or a SAS question. Did I write anything on the dotted line, the altitude? Okay, then SAS is out. It's going to be, let's do it. Don't write in degree measures. H is for hypotenuse. What is it in this diagram? I'll call him somebody. 18. X plus 75. Remember, when we say hypotenuse, we are talking about the large right triangle. L is for leg. Leg of the right, full right triangle we started with. Give me the leg measure here. Woo! 19. Yeah. Equals leg. 14. Oh, can't fool you. Same leg. But I'm going to fool somebody here. Segment, since there's two of them. 25, which one? 75. Why'd you pick that, Aaron, and not X? You got to pick the one adjacent to the leg in the problem. Ooh, this looks hardcore, huh? Look at this proportion. Can you handle it, honors kids? 75 times X plus 70. There's no factoring here, so don't get crazy. Tomorrow, different story. Yeah. I have no 75 squared. It's 5625, Michael. This one's 7,500, right? Yeah. 25? Okay. Again, let's put those pens down. Hills is the most direct way to get the final answer. There are other methods. You could have done Pythagorean theorem on that right triangle to find the altitude and then done SAS. I have seen kids in the past. It's a lot of work, but they find this angle here, I think, or maybe, no. They find that angle there. Then they start finding using sine, cosine, tangent. Then they start finding sides using sine, cosine, tangent because they're so locked in to sine, cosine, tangent. And does this end up in radical form at all? No, we got 25. So eventually you're going to get a whole number, hopefully, if you do it correctly. So there's other options. Okay. All right. Everybody good? Okay. And we got one more. A little word problem. I don't know if you want to copy it down or just watch again. All right, we got 3 friends camping in the woods. No Big Al here. We got Bert, Ernie, and Elmo here. Showed a little my soft side here. I'm going Sesame Street. Anybody want to talk? Favorite characters?
The one that's in the one that goes in the trash can. Oscar.
Yeah, shockingly, that's my favorite too. Oscar the Grouch. I know that surprises some of you. Yeah. The Count was okay because he was with numbers. Anybody? Snuffleupagus? Oh, that's old school.
That's a Big Bird, okay? I'm a Big Bird type of
Oh,
guy.
yeah. Okay, real quick here. We have these three friends in the woods. Their own tent. Their tent forms a triangle. So we got Bert, we got Ernie, and I can't use E again, so I'm just going to use O. Elmo, all right? Bert and Ernie are 10 miles apart, 10 meters apart. The angle formed at Bert is 30. The angle formed at Elmo is 105. How far apart are Ernie and Elmo? What's your move? Do I have all that right? Oh, Elmo 105. Yeah, okay, I got E. Let's try that again. 105. There we go. What's our move here? Find the third angle. Okay, we could. Which would be what? 45, okay. What's your next move? Got to find this side. There's no right triangle here, so all that SOHCAHTOA business, don't give me it. Kevin? Were you going to use SOHCAHTOA? Oh, okay. You can do law of sines, yeah. You can't do cosines. Why? I don't have all the three sides, correct. So I can do law of sines. What's law of sines going to look like for me? 10 over sine of 105 equals x over sine of 30. Yep. And whoa, before we go calculator, you should be able to answer this question. Ready? Should my answer be less than or greater than 10? Why? Because it's across from 105. This side's across from 30, which is less, so the side should be less. There you go. Acting like you know something. Good, kids. I think you get about 5. I didn't put any rounding directions on here, but if you round it to the nearest whole number, I think it's 5 meters. What is that? All right. Going back to the beginning, anything else you want to touch upon? As soon as you get in here tomorrow, you're going to get a test because you're going to need the whole period. I know this is a little deceiving, but these take a while. Okay? Some of these questions take a while. All right? And this may be deceiving too. Why is it only 34 points when you call it a test? Well, how many quizzes have we had? 2. So that second quiz kind of makes up for what's missing from the test. So, and no formulas given tomorrow. Remember that. There's no need. I guess you could have your formula sheet if you need a quadratic formula, but that's it. Yeah, what do you got for me there, superstar?
Depression. The angle of depression.
Okay. You're on top of a building. You're on top of a building looking down. Angle of depression, let's say, is 33 degrees. Not here. 33. Right here, as you look down. What can I do with that angle? There's 2 different ways I could bring it inside the triangle. How? I could use alternate interior angles and say this angle is 33, or the one next to it is complementary. Okay? All right, guys, it's time to get after it tomorrow. Hopefully you're not going to be surprised by what's on there. You put in the work.